Hi guys, today we'll talk about relations and functions. So before understanding what is a relation, we should understand what is an ordered pair. So ordered pair A comma B written like this, where A belongs to some set A and B belongs to some set B. Now if we accumulate all such ordered pairs from set A to B, we call that set to be a Cartesian product of A and B, like, right? So how many such numbers are possible? That is the cardinality of set A into cardinality of set B. These many ordered pairs are possible from set A to set B, right? So we know Cartesian product now. Cartesian product is a set of all possible ordered pairs from set A to set B, and Cartesian product could be written like this, right? Okay, you understand Cartesian product now. What is relation? Relation in simple terms is a subset of Cartesian product of two sets A and B, where A represents the image part and B represents the image part. We call when we study function, we will define A as a domain of the function and B as a range of the function, right? Essentially I should say codomain, not the range, but range is a subset of codomain, right? So relationship from set A to set B is a map of element from A to element B through some formulae. Okay, like here we have mapping of A to 1, where A belongs to set A and 1 belongs to set B. Like P is mapped to 4, E is mapped to 4, C is mapped to 2, and so on and so forth, right? So A forms the domain part of this relationship, and all the mapped values like 1, 2, 4, 5, these forms the range part of this relationship. But keep in mind that B is a set containing 1, 2, 3, 4, 5 and 6, where 3 and 6 are not mapped to any value in the set A, right? So this whole set is not arranged for this relationship. This set B is called codomain, where codomain represents the whole set from which range is drawn. So range is essentially a subset of codomain, right? I think it is clear what is domain, what is codomain, and what is range, right? Like okay, so we have mapping from A to B. So based on mapping, how elements are mapped, or how many elements are mapped to how many elements of from set A to B, right? So we define mapping in following types: one-to-one mapping, where each element from A is mapped to each a distinct element from B, right? Like A is mapped to 1, B is mapped to 2, B is mapped to 4, C is mapped to 2, and like so on and so forth. It is not necessary that you map all the elements from B to some element from A, right? You can have one or more elements which are not mapped to any element, but wherever mapping exists, it is one to one, where one, right? I understand. I think you have understood this. So one to many. Okay, one to many is one element from A. At least one element from A is mapped to more than one element from B. Then we call that relationship as a one to many relationship. Okay, again you have elements which are not mapped to any element in set B, right? Onto mapping is nothing but a mapping from A to B where no element is left unmapped. That means all the elements present in A and all the elements present in B, they are mapped to at least one element from each set. Okay, like one is mapped to 2, so one is mapped to A, and B to 4, C to 2, E to 3, and so on and so forth. So this is essentially is onto mapping. When a function has onto mapping, we call that function surjective function. Okay, surjective relationship. When a relationship is onto, we give it another name, surjective. And when a relationship is one to one, we call that relationship as injective relationship. Okay, these two names are synonyms for one to one and onto respectively. Now the relationship which follows injective and surjective rules, that relationship is called bijective. I hope till now it is clear, and it will be helpful when we will study about functions. Okay.